Length of confidence interval and appropriate sample size. What is confidence interval? Refers to the probability that a population parameter will fall between a set of values for a certain proportion of times. The length of a confidence interval is the absolute difference between the upper confidence limit and the lower confidence limit. That is, LCI, length of confidence interval, is equals to UCL, upper confidence limit, minus LCL, lower confidence limit. Now, let us proceed with the first example. Find the length of the following intervals. P in between 0.357 and 0.603. When the number has a lower value, then it is considered as lower confidence limit. And when the value is higher, then it is called the upper confidence limit. Now, let us subtract the given intervals, and the equal is what we call the length. Now, let us find the length of a confidence interval for population proportion P. As you can see, you can clearly identify where is the UCL and LCL between the formulas because of their signs, positive and negative. In order for us to find, we are still going to follow the same formula and method. Now, what is going to happen is these two P hat is going to be cancelled and be considered as an imaginary one. And now, we are going to add these two with the result of LCI equals 2 Z sub alpha over 2 times the square root of P hat multiplied to 1 minus P hat over N. This portion of the result is what we call the margin of error, or E. In other terms, we can just simplify the answer by putting LCI equals 2E. And now that we are done, let us proceed with the second example. Find the length of the confidence interval given the following data. P hat equals 0.25, sample size equals 400, and a confidence level of 95%. Our alpha is 5%. Or 0.05. Now, we are going to find the alpha over 2. So with the given alpha 5%, we are just going to divide it with the over 2 equals 0.025. And now, we are going to find the difference in which we are going to subtract the 0.5 and the 0.025 with the result of 0.475. And now, we are going to find the Z value, which is the 95% confidence level, or 1.96. And now, we are going to solve the given formula, which is 2 times 1.96 is equals to 3.92. And 0.25 times the open and close parenthesis, 0.75 is equals to 0.1875. And now, the 0.1875 is going to be divided by the 400. And with the result shown, we are going to multiply it with the 3.92, in which the equal is 0.848, or round off 0.085. Determining the sample size. The following are the two formulas. When an estimate P hat is known, and when an estimate P hat is unknown. So you are thinking, why is there a 0.25? If our P hat is unknown, we assume that the equivalent is 0.5. The same with the 1 minus P hat. So what we are going to do is to multiply the p hat and 1 minus p hat. And that equals to 0.25. And that is the explanation why is there a 0.25.
Next is for interval estimate of population mean with known variance. Formula to find the length of the confidence interval. So this is the formula, the LCI. The alpha over 2 times and the standard deviation or the population standard deviation or all over the square root of n, and that is the margin of error. So we can say 2e is the confidence interval. The margin of error in a confidence interval, the range of the value above and the below the sample is statistic, so wherein C sub alpha over 2 is the C value, so that is the confidence coefficient, or we can call it critical value. Our lowercase sigma, that is the population standard deviation, and is the sample size, and the alpha is the confidence level, that 1 minus alpha. So we can use also the table for the C-scores. We commonly use confidence interval. So for example, find the length of the confidence interval given the following data. The lowercase sigma, that is the population standard deviation, which is equal to 0.3, and the sample size, which is equal to 60, and the confidence level is the 95%. So let us use the third formula into decimal. In our third formula, the first step is to get the alpha. So to get the alpha, the confidence level of the 95% will be subtracted to 1. But you have to change first the 95% into the decimal. So it's 0.95. So we will have now 1 minus 0.95, and therefore our alpha is equal to 0.5. So that is for one tail. So let's just divide our one tail by 2. So alpha divided by 2, so that is 0.5 divided by 2. Therefore, we have two tails of 0.025, so that's the difference between left and right. So let's take that area and subtract it from 0.5. So why 0.5? Because we're only going to use half the area of the normal curve. We will have now the area of 0.75. Then if you look at that in our table C-course, it has a C-course value of 1.96. Okay, let's have here the normal curve. So this is our 1.96, then 1 2/3, and to get that 2/3, we first need to solve our alpha, which is 1 point, and then the alpha. Then after we get the alpha, we divide the alpha by 2 to get the 2/3. And then this length, this is what we'll take. But if this is a full one, that is the 95%. And the 95%, that is the confidence interval. So we will take the length of the confidence interval. So to get the length of the interval is the Z alpha over 2 times the lowercase sigma. And that is the population standard deviation over the square root of n. So what's on the left side is the same of the right side. So our formula is times 2. So using the area under the standard normal curve table, which is a Z sub alpha over 2 is equal to 1.96. So let's use the table, although we already have the previous value. So we can also use it. If you don't want to use the longer table, you can also use the table Z-scores. We commonly use confidence interval, so the 95%, that is the given. Let's just look her and the table. So the 95% is equivalent to 1.96, so it is 1.96 in the standard normal curve. So we will have the LCI is equal to 2. So you just copy the 2, and then our C sub alpha over 2 is 1.96. And then our lowercase sigma, the population is standard deviation, is 0.3 over the square root of our n is 60. And that is the sample size. Then let's first take the square root of this 60 before we divide. So we will have now the 2 times 1.96 times 0.3 over 7.7460. So that is the square root of 60. And then we can divide. Let's multiply the 2, so that is 3.92. Then when we divide by 2 the 2, that is the 0.387. Therefore, our LCI is equal to 0.1518. So, let's have another example. Find the length of the confidence interval given the following data. So, we're going to use first one. We need 2 degrees of freedom. So, our DF is equal to n minus 1. So, our n is 15. Let's subtract 1. Therefore, our DF or degrees of freedom is equal to 14. And then the second step, let's take our alpha. So let's get an alpha. Let's take it or use the confidence level of interval. So let's change the 99% again into a decimal number. So that is a 0.99. Then let's just divide by 2. So our 2-tailed is 0.005. So let's look at that our table. Our DF is 14. And then we have your 0.005. And then let's just lower it to 2.977. Then let's find the DF of 14. And so this is our T alpha over 2 equals 2.977.